Good afternoon. This is Madhav Takal from Rotational Institute. I'm a crop and weed scientist. Today, I'll be talking about weed management practices in organic no-till system. Before I start this webinar, I would like to say a few things like this video is going to be recorded and posted within a week. If you have any questions, please give them to Q&A section, not in the chat room. If you have any questions, further questions, let us know. I'll be showing the contact information at the end of this webinar. And then if you have any technical difficulties, please call the number on the screen, 610-683-1442. So I'm going to start talking about weed management, and thank you for joining this webinar. Organic farming. So of course, you heard this terminology before. This is basically a production of crop, animal, and other products without the use of synthetic chemicals. For example, chemical herbicide, pesticide, insecticide, fungicide, or any type of synthetic chemicals. Transgenic species, for example, GMOs, antibiotics that we use in poultry, growth-enhancing steroids, and other chemicals. So the motive of organic farming is to build a healthy soil, to produce healthy food and healthy plants, so our environment and all of us will be healthy. So basically, as I mentioned, there is a distinction between organic and non-organic inputs. So the inorganic inputs in agriculture are the genetically modified seeds, transgenic seeds, chemical fertilizers, pesticides. Those are on the right-hand side, and then these are not permitted in organic agriculture. And on the right-hand side, we can see like a crop rotation, cover crop, compost, manure, and bioherbicide. And these are basically the tools or the inputs in organic agriculture. So before I jump into the non-chemical weed management practices, I would like to highlight a few things about the herbicide, why it's not safe, and why we are emphasizing the organic weed management. So herbicide, this is the diagram from EPA. We can see there's no safe limit. I mean, the environmental discharge we can see from the industry, urban development, agriculture, and forestry. So there are several ways that it can end up in water or in the sediment, and they are highly persistent. So they could contaminate water from the land cover alteration, precipitation, timing and rate of application, and environmental persistence. And ultimately, this diagram shows that these chemicals, they end up within the tissue or the genetic structure of the plants, and then invertebrates and amphibians. So it could change the ecosystem process and the overall environment. So, and there are so many like literature we can find online, like are herbicides a once a century method of weed control? I read that article published in 2017 from Davis and Frisbol. And according to the paper, like it's very, the herbicides that we are using, like glyphosate, which are everywhere. There's no place on earth which is technically glyphosate free. Those were even traced back in Antarctica as well. So we are open for almost everything. If we see the list of herbicides that we use in US, most of those chemicals, those are banned in European Union, Brazil, China, and many countries. So WHO, which actually categorize those extremely hazardous pesticide as critically or highly active ingredients used in agriculture. So more than 500 active ingredients have been in use in the US, and they are in trade for thousands of brand names. So we are using the pesticides which are not even allowed in many countries in the world. And because of the increasing and the tremendous amount of herbicide we use in conventional agriculture. Herbicide resistance is becoming a problem, and there are 464 unique cases of herbicide resistance, with about 267 species belongs to 40% resistant to different type of herbicides. For example, associase inhibitors, that's the and then synthetic oxygen inhibitors, ALS, photosystem second inhibitors, and EPSP synthase inhibitors. And those type of resistances that were recorded since 1960s, when we started spraying herbicide in our crops. And the first reported resistance was in 1968 with triagens. And if we see the single most used herbicide, glyphosate, by year, we can see the exponential rise of the use of that herbicide until 2012, and then 2016. There is a level of used. However, the cost of glyphosate resistance is really high because of I know it's like a price increase. Not only price increase, because of the price increase of the herbicide is more than 10 billion a year, but there is other things coming up in addition to that. Those are the yield penalty because of the resistance, and then the environmental and social cost. And then there is another grand challenge that we have is global warming. So what it does to weeds and crop is it changes the range of the weed. I mean, the types of weed, and then the niche of weed as well, because of the change in temperature, precipitation, and the environmental variables. For example, here are some common weeds. I mean, there is a report of having increasing number of thermophil weeds, for example, Panicum, Dichylomiflorum, and then Amaranthus retroflexus. These are the weeds which were reported in the Northeast. I mean, reported like their increase in density has been reported in the Northeast. I mean, those were not that problematic before. So changing climatic variables could change their niche and then their trait as well. They could develop like more resistance to herbicide and then resistance to other weed control techniques as well. So, of course, I mean, growers have concern about changing world. I mean, as Robert Miller said, like, I'm no scientist, but global warming is here. It is that it is. So that's the challenge. And then another challenge is the rising population is going to be 10 billion in a few years, and our productivity is not going to increase as compared to the population growth. Even we can see in the developed countries, the productivity is actually declining because of the resource exhaustion as compared to the developing countries. So this is something that is going to be addressed. I mean, and in organic agriculture, it's not easy if we eliminate herbicide from our weed control program. For example, we can see some pictures here on the left-hand side. Is more common in agriculture, like 20 up to 50% yield loss could happen if the available weed control tool in organic system, we don't use them properly. That's why we need to integrate cultural, mechanical techniques of weed control, and it's really tricky. And in controlled conditions, if there is no weed control techniques, then the yield loss can be more. And according to Weed Science Society of America, in control plots, if there are no weed control, then yield loss in soybean is 52% around, and then corn is like 45%. So yes, I mean, eliminating chemical from weed control program is not easy, but there are some solutions which I'm going to talk about in this webinar. This is the one, like a traditional way of non-chemical control. I mean, the organic weed control, growers, they till their plots to control weeds multiple times in a year. But this is not a not good alternative because it trigger erosion, and erosion is the major problem in the US as well. Like 1.7 billion tons per year is the loss of soil, and then that's account for like 1 to 5 tons per acre per year from our arable land. And the alternative is no-till. However, it is winner only with glyphosate especially in conventional system, because in conventional agriculture, herbicide can kill those weeds. And in organic system, if we are saving our land by not doing tillage multiple times, then yes, it is very, very difficult. And here we can see, even in conventional system, the no-till is exacerbating herbicide resistance. I mean, applying herbicide to kill all the weeds in no-till system is not a really solution, even though it seems like the conventional way of doing no-till is the winner. That's why we have developed some tools and technologies that I'm going to share in this webinar as well. So key to the sustainable solution of the problems that were created by the conventional system, as well as the traditional organic system, is to think like holistically. I mean, approaching several ways that can save and conserve the resources as well. For example, imagine yourself as a mechanic. You have drills, wrench, screwdrivers, and everything to fix the car, to fix the machine. If you just have a wrench or hammer, what are you going to do? So you need all sorts of equipment to fix the problem, to fix the machine. Just like that, in agriculture, we need several tools, diversified tools to control weeds. For example, cultural tools like having cover crops or row spacing configurations, planting densities, adjustment, and having managing crops with cultural means is one way. Mechanical way of controlling weeds, if we combine cultural means with the mechanical tools, for example, rolling crimping or flail mowing or other tools, then it can be an integrated package. And in addition to those, we can add some biological tool and then the non-synthetic chemical. For example, there are some bioherbicides in the market which are only listed as well, organically certified. So we can even use those bioextracts to control some weeds. And by having all the available tools of weed control, we can build up one effective integrated weed management package for the organic cropping. So it would be really wonderful to understand like the nature of cover crops and crop rotation, which changed the scenario of organic agriculture as well. For example, we are pursuing weed control and our resilient agriculture system in cover crop based rotations. So I'd like to explain how the cover crop works. So here's the diagram adopted from Merske from USDA. So there's a line in the middle and then cover crop residue on the top, and below ground is the soil. So let's imagine there are dormant seed bank, a lot of seed bank, and of course if there is a residue on top of it, so the attenuation of germination cues, for example, the environmental drivers like light, temperature, rainfall, oxygen, could block dormant seed bank to go to active seed bank. Not all, but certain fraction of those dormant seed bank. And after that, cover crop, it also retain the soil moisture and also physically interfere the active and germinating seedlings of the weeds, so it can reduce the weed pressure in the crop. And there is another way the cover crop act on the weed is by releasing allelochemicals or by doing phytotoxin inhibition. And also it can alter the C-N ratio on the surface in the soil. So that's how it actually suppresses the emergence of the weed seedlings. And even with the thick cover crop residue on the top or on the surface, we may still see a few weeds. Those weeds can be competitive in the growing season, especially in the summer. And that's where we need to control them and apply some other tools of weed control. So here I would like to explain how the cover crop based one-pass no-till system works. So we plant winter annual crop, for example, cereal rye. We can have other cover crops like hairy vetch, crimson clover that we can plant. So let's imagine like we planted cereal rye in the fall, and if we establish in September, it would be ready to terminate in May, last week of May or so. And then we can terminate the cover crop mechanically in the spring and plant corn or soybean or other cash crop that we want. So here's the tool, roller crimper, which is mounted on the front side of the tractor, and there is a planter at the back of the tractor, so it can be a single pass, one pass. You don't need to go with the crimper and then come back with the planter. So it's a time and cost-saving technology as well. And cover crop residue become a weed suppressing mulch after this. So this is a three-step process that you can build the cover crop mulch and suppress the weed. So here are some tools of that could make it happen. For example, this is the roller crimper. This is something like a 2,000 to 3,000 pound cylindrical roller. It has the chevron pattern blades. These blades are the blunted blades, not really sharp. They just crimp this stem, so it would be intact with the soil surface, or the entire plant will be intact, but it will be crimped in such a way that it will die immediately after termination, because we don't like to, or we don't want to adjust soil moisture because of the transpiration. So cereal rye is the really effective cover crop that can be terminated like effectively by using roller crimper. And in addition to that, hairy vetch, field pea, crimson clover, and oats, and some other cover crops can also be terminated by using this tool. And there are several modifications of this roller crimper. You can fill the water inside it and make it more heavy. So yes, and it's not very expensive as well. And there are some other equipment to kill the cover crops. For example, the cultipacker can be used. Flail mower, it can actually cut the cover crop residue. And then there is another one, we call it dawn roller. So the multiple rollers which are attached right in front of the planter and is connected with the hydraulic system. And here is the stalk chopper, our haybine mower. We can use several tools to kill the cover crops. However, their efficiency, their effectiveness are really different. And it's not that very simple, like growing cover crop and then terminating it and having weed control. That's because it's driven, the weed suppressive effect of cover crop is driven by its biomass in the spring. And there are a lot of researches, publications about what are the challenges of having rotational no-till soybean production or the crop production, and how the cereal rye or cover crop biomass affect the weed suppression. And based on the previous experiences, our overall research question that, and then the research program that we have developed is trying to fine-tune cover crop based system to design ecologically driven weed management. So here's the one, this is about when you should plant cover crop to get the appropriate or the sufficient enough biomass in the spring to get to maintain the residue, which is about 3 to 4 inch thick. And you should plant your cover crop in the right time. For example, rye should be planted in mid-September in Northeast and should be terminated. Like there are 2 lines. The dotted is the line which terminated in May 20th, and the another line, the solid line, is where the cover crop cereal rye was terminated in May, at the end of May. So of course, giving more time, more growing degree days in the spring, we can allow cover crop to grow more and accumulate more biomass. But we can play with this, like playing with the planting date and the termination date. We can create, or we can have the biomass, desired biomass, that can suppress the weed in the spring. So yes, and we tried like planting from the recent experiment. We tried planting cereal rye in September and October with 4 different termination treatments, like full tillage, plow and cultivate in the spring, and the reduced tillage, like rolling crimping, using dawn roller, and then mowing and tearing the cover crop. And looking into the result, like comparing plow and cultivate PC, IJRC, INJ roller crimper, that's the standard roller crimper that I showed. Dawn roller crimper is on the top, DRC, mow and tear is MNT. And we have result from 18, 19, and 20 regarding the total wheat biomass on the y-axis, and September and October, S and O. So that's how we can read how much total biomass we got in the middle of the season in soybean. So here we can see that in the first year, there was no differences among the termination methods, even though it's numerically different, but statistically not very different. But it tended to have, variation among the treatments. But in the second and third year, we can see, especially with the September planted cereal rye, the INJ roller crimper, or the standard roller crimper, did a great job. So, reducing the total wheat biomass now as compared to other termination methods. And we actually determine the biomass of the broadleaf weeds and grassy weeds. So mainly the plots were dominated with grass, and we saw very few broadleaf when we terminated cover crop with roller crimper. We noticed that the IJRC roller crimper actually uniformly created mat as compared to dawn roller crimper. Even though the bounce back was low with the dawn roller crimper, there was an opening on the furrow, a little bit more opening, and I saw like more within row weed proliferation in dawn row roller crimper. And mow and tear could be due to the high decomposition rate. The weeds were coming back in late season. However, with the roller crimper, it was knocking or keeping the weed population low throughout the season in soybean. And we have noticed like, rolling crimping pattern can also affect the weed proliferation in the spring or summer. Let's take an example, like we plant cover crop like in a rows like this in the picture. And in the spring, we really don't notice like whether they were planted in rows or not, but still they are in rows. And it matters as well. We notice like, if we are rolling like a parallel going through the rows of cover crops, the bounce back would be high, like in this picture. And the surface mulch may not be that uniform. And I noticed like it tends to remain green for more than 2 weeks. That's not good. We need to terminate or quickly kill the cover crop in the spring to facilitate cash crops. So one thing we noticed was when we were rolling parallelly, the weed pressure was more. And when we were rolling and planting on the perpendicular direction of the cover crop rows, weed pressure was really low. And one major thing was the bounce back. There was literally very, very minimum bounce back, and surface mulch was uniform. very low amount of weed as well. And maybe there is an angular pattern that we can make as well, but there was an effect of cover crop rolling crimping, and we are going to test it. So I believe like you could try adjusting your rolling crimping pattern as well. And another strategy is the crop rotation, diversification, which is really necessary in organic weed management. For example, crop rotation actually breaks weed life cycle antitillage seed bank, because there are a lot of weeds which are associated with certain crops. And if you break the crop cycle, that means the associated with weed life cycle can also be broken. And actually the crop rotation changes the soil environment for weeds, because different crops have different requirement for the water, nutrients, and they build soil organic matter and then change the soil physical, chemical, and biological properties in different ways. So we also change the environment with different crops. That means that changes the environment for the weeds as well. That means if you have heard about the effect response relationship between crop and weed, that means if there is an effect in the environment and the response to the crop or the weed would be different too. It alters the stress and mortality factors. For example, some crops, they could have the allelopathic effect. Like, for example, if we are rotating our crop with buckwheat has a allelopathic effect on several weeds, and that means we can alter or aid, manipulate the stress and mortality factors as well. That could alter the weed composition and potentially minimize the problem of the high weed pressure. And it changes the weed community assembly. And also the major thing is by having the diversification rotation, we are building healthy soil that will allow to produce healthy crop. And of course, if we produce healthy and more competitive crop, then that would compete with the wheat as compared to the unhealthy soil and crop. So there are some examples, here's the meta-analysis from 51 research studies which showed like crop diversification effect and weed density was stronger, that reduced 49% density in zero-tillage system than in tillage system from multiple studies. And there was another study like the crop diversification and parasitic weed abundances, and it showed that crop rotation and intercropping that can reduce the weed density significantly, like from 67 studies and 1,525 paired observation. Scott and Frankton, they actually recorded like a huge significant reduction of the weed density in cropping system having a diversified crop rotation and intercropping. So here's the one of the example of the how diversified or phenologically diversified crop rotation can affect and alter the weed community. For example, here's the rotation, cover crop based rotation between hemp and malt barley. And there is a cover crop in the winter, which is the mixture of H and P. So of course, the cover crop can add up the nitrogen, build organic matter, improve the soil health. And then if we plant hemp after that, it depletes. For the malt barley, of course, hemp utilize the nitrogen and it moderate the amount of crude protein in the grain of malt barley, which is about 12%, 9 to 12%, appropriate for the malting quality of the barley. However, the another benefit is the suppression, weed suppression. Hemp can reduce the weed density. In some of our plots, we have seen like more than 90% reduction of the weed population in the summer. So here's the example of the how inclusion of hemp could reduce the weed pressure is Here in the conventional system, in the no-till system, on top of cover crop residue, we couldn't establish the hemp like with the proper plant density. But if we focus on the conventionally tilled managed hemp after the cover crop, then we can see a reduction of the weed abundance. As we can see, the weed pressure was significantly lower as compared to the other systems. So, I mean, the broadleaf grass and sages, all types of weeds were reduced by including hemp in the system. So there were the different fertilizer experiments, and there was no, some differences among 0, 50, 100, and 150 kilogram nitrogen per hectare. Now, however, the differences can be seen among the systems. For example, no-till, no cover crop. If there was no tillage and no cover crop, the weed pressure was really high as compared to no-till, cover cropping, and conventionally tilled systems. So this is the example of how the hemp biomass reduced the broadleaf weed biomass, and there's a significant relationships between those two variables. Like the hemp biomass exponentially reduced the broadleaf biomass when the biomass was above 4 megagram or the ton per hectare. We can see the broadleaf biomass has been reduced to less than 0.5 gram per meter square, which is really, really low. And as we can see in the picture, we planted barley after hemp, and the field was really clean where the hemp biomass was really high. And we haven't seen any weeds in the plot where where we have seen hemp growing, like having more than 4 or 5 ton per hectare biomass. And another way that we are working is like having different plant configurations, like planting soybean, cover crop based soybean in different row spacings, like 7.5. The middle one, this should be 15-inch and 30-inch. I'm sorry about the typo here. So left-hand side is 7.5, the middle one is 15, and the right-hand side is 30-inch wide spacing of the soybean. And there are 3 densities of the planting densities. The lowest one was the 370,000 seeds per hectare, and the middle one, D2, is 463,000 and 555,000 seeds per hectare. 3 densities. We tested the interaction between the row spacing and then the planting density. So we found that the weed density can be reduced with the narrow row spacing, like 7.5-inch spacing. Specifically, the hypothesis was like the high density could reduce the weed pressure, but it didn't do that way in narrow spacing, where even the D1, or the lowest density planting density at narrow spacing, was doing well in reducing total density as compared to other high density soybean. Here with 15-inch, there was like a high density reduced the weed density, and in the 30-inch spacing, the high and low density. I mean, it's not the clear pattern, but if we see among the row spacing only, we can see like the narrow spacing can reduce the overall total weed density. And the weed biomass, I mean, the result, if we compare from the density to biomass is not like a significantly different among the row spacings. However, with the narrow spacing, there's a tendency of the reduction of the weed biomass as well as compared to the wide row spacing. So wide row spacing allow weeds to grow between the rows, where the narrow rows, the canopy closure would be faster, and then it can actually limit the light intensity on the surface. So that way it can compete, crop can compete with the weed. And here's the probability of weed emergence in different row spacings. For example, 7, 15, and 30-inch, we can see the broadleaf weed emergence, probability of broadleaf weed emergence. We can see three different colors: blue, yellow, and red. The red, the orange, red color is for the 30 inch. So the more area means more probability of emergence. So broadleaf weed, their probability of proliferation and the broadleaf weed in grasses were more favored by the wide row spacing as compared to the sages, because the sages are more in narrow row spacing, 7 inch spacing, as depicted by the 7 inch spacing, whereas the sages are not really in the 30 inch spacing. So having agronomic configuration that could change the weed community composition as well, and that would allow us to see what type of weed management would be effective for our cropping system. And here's the integration of how we can apply how we can utilize the high residue cultivator. This is the high residue cultivator. It has the shallowly, pieced blades, which can, it's not going to turn over the soil, but it can just cut the soil surface like 2-3 inches below the surface. So it runs between the crop rows and kill especially the perennial weeds. So we have, a few years ago, there was a research, and it found that if we cultivate with the high residue cultivator about like 5 to 6 weeks after planting, then it would allow, then that would reduce the weed pressure tremendously as compared to the control system. And here's the another tool, electrocution. We are trying to ensure, like, does it suppress weeds, what it does to crop, and then how to make it work. So here's the density and biomass. As we can see with the high residue, we combine with high residue cultivation and electrocution. So there are like high residue cultivation only, high residue cultivation and electrocution, and then the combination of 2 electrocution with the high residue cultivation. So we collected the density and biomass and found like there was no such a difference among the treatments, and like there was no difference with the control, even though we applied electrocution, applying electricity to control weeds. However, at the late season application of the electrocution actually reduced the biomass as compared to control, or the density as compared to control. However, there was no difference among high residue cultivation and then the electrocution. Like the electrocution alone didn't actually differ from the high residue cultivation. So there was no benefit of having applying weed chaper in the system. So here's the soybean biomass. We have seen like the late season electrocution inhibited the growth of the biomass. So in the control plot, the soybean biomass was actually higher as compared to the late season electrocution here. High residue cultivation, they were comparably similar with the control as well. So the biomass yield actually reflected to the grain yield of soybean, where the grain yield was also negatively impacted by the electrocution, maybe due to the inhibition of the growth. So it indicates that we need to find more ways to integrate electrocution in the system so we can build an effective system to control the weeds. And maybe the reason is like we need to see whether it's good or bad for the crop. For example, here in the picture, there are some like injuries to crop, and there are some patches which are not affected by the electrocution as well. And the flame weeding, for high weed pressure, we tried this to control some weeding this spring, but with the high weed pressure, it may not be very effective, can work for small seedlings if it is less than 2 inch height. And we believe like if we drive the tractor slowly, less than 3 miles an hour, then might kill the small seedlings, and apply when the soil is dry and it is effective in early spring. And I would suggest like don't rely completely on flame weeding if you are controlling weeds in early spring, because we tried to control weed in no-till plots when we established hemp. So this is the graph of the hemp stand density. And we can see in no-till, the stand density was reduced tremendously because we did flame weeding and then planted hemp, but it didn't kill the weed. So stand establishment of crop was severely impacted by the weeds. So it was because of the ineffective control measure from the flame weeding. But of course, we believe like if the weed biomass or the pressure was low, or if the weed seedlings were small, we could kill the weeds effectively with flame weeding. And this is the another tool like the mowing between the rows, crop rows, especially in soybean. This is the video from Cornell University, and this is in the early stage of research. We are going to try this from this season, and we saw some of the examples like it can like kill the weeds between the rows. However, we should be more careful about, like some weeds, their physiology can be changed when we mow them. They could be even more aggressive, and still there are many things that need to be found out. But it seems like mowing could be a tool to apply in organic weed management program. And there is another one that I would like to see. I talked with John Baker and Jonathan Alexander from USDA and Brandon from Land Institute to try out Kura clover, how this living mulch can complement soybean and corn and reduce the weed pressure during the season. So it's going to be started, and I believe like this type of perennial rhizomatous short growing Kura clover, if we establish in like, there are two ways that we can establish Kura clover, like establish Kura this year and plant corn and soybean next year, or like frost seed your Kura and plant the crop in the same season. But I wouldn't prefer like planting in the same season. But we are trying to compare like establishing Kura clover and the cast crop in 1 year versus like the following year. So we can see like what type of management practice could allow Kura clover to establish well and suppress the weed as well. And there are some other varieties like the everlasting hybrid between that's the hybrid between Kura and then the white clover that can be grown. That type of clover can be grown like faster as compared to the original Kura. But the data is limited, and we are still looking into how well this can work. But it seems like from the USDA ARES experiences, and John shared me some of his experiences. He mentioned like this is an amazing crop, and we should try it. And this could be a way that we can suppress the weed as well. And there are some other like tools like applying essential oils like basil, lemongrass, clove oil, and other like mint oil to suppress the weeds. Like there are some research which showed the inhibition of the suppression of the weed comparable to the glyphosate as well. I mean, with the adjuvants, there's a way like the efficacy of these type of bioherbicides can be increased. And these are some of the interesting things that we can buy, we can find in the market as well. Those are the only listed certified bioherbicide that they can be utilized to control the weeds. And here's another example of how we can deplete the seed bank by reducing the weed seeds, removing them after the harvest. There are some mixed results from around the world. It's not going to give you like an immediate impact. However, this is the slow process, like it reduces the weed seed bank over the time. And however, the impact driven, the drum attached to the combine harvester, you can see in the picture. This is a relatively expensive equipment to purchase and mount in your combine, and it gradually depletes the seed bank. And we have found from different researches, like from the Virginia Tech, in fact, the Italian ryegrass and ragweed densities were effectively reduced. And from Australia, there was a great, like a 95% removal of the radish seed, and it's a really great number. and up to 100% destruction of the giant ragweed seed. Those were the results shown from the research, and it seems like this equipment's applicability is really worthy in organic crop management. So the major takeaways are like weeds can effectively be managed by applying ecological principles. Mechanical tactics should be integrated with cultural weed management practices. Changing agronomic configurations, for example, the changing row spacings and then the plant density, although they were not always suppressing weeds, they can have profound effect on weeds. And electrocution is a double-edged sword, means you're not only killing weeds, you're also, if we don't find some other different ways to apply it, then it can also, affect the crop as well. So there's more research needed to do the electrocution. So we are continuing to investigate how it can be more useful in cropping systems. And phenologically diverse crop rotation, for example, integrating with hemp, like a forage crop and other different type of crops other than the grain crops in the grain crop rotation is more critical for reducing the weed seed bank. So this way we can ecologically manage the weeds. So if you have any questions, please reach out to us. So here's my phone number and then my email address. And you can also contact Justine Berkeley and Maria Pop in our education department as well. So thanks so much for attending this webinar, and I will try to, if you have any questions, please have them in Q&A so I can answer them. So here's the one question I would like to answer is, what is the cost and time consuming comparison of herbicide versus cover crops? Yes, so it's a great question. Like we have a farming system trial where we compare the conventional crop management with the organically managed systems. One is manure-based, and then the another is the legume-based systems. And there, I believe, our economists and scientists, they compared how the herbicide and cover crop, they differ in terms of cost and of course the labor consumption as well. And it was found that the profitability or the net return per hectare or per acre was higher mainly with the manure-based system, because the productivity of corn and soybean was high in manure-based system as compared to legume-based and then the conventional system. Because the another reason was not only the productivity. The productivity of the manure-based system was comparable to the conventional, like the herbicide-based system. However, it's not only about the comparable productivity, it's about the price premium. The manure-based system was profitable with or without the price premium, whereas the legume-based system was profitable with only price premium. As compared to the conventional system, yes. And the another question is, here in Philippines, what living mulches could be used? Okay, so when we talk about the living mulch, specifically, the one I was talking about was the Kura, and I believe I'm not exactly sure about the weather and the environmental conditions in the Philippines. However, maybe you could try some type of legume, like it may not be exactly the Kura, but some type of clover could be tried in Philippines to have some living mulch, I believe. And I've seen in India or in some other South Asian countries, the growers, like they are really doing some handy practices. For example, maybe you have seen like the intercropping corn and soybean together and some beans. They intercrop, and well, that's the typical intercropping. But when we talk about the living mulch, clovers and other forest crops, those are some that we can try even in the subtropical environment, I believe. The one, here's another question from Taylor, and the one past no-till seems great. Have you found any results with poor germination of cash crop due to allelopathy in cereal rye cover crop? I have heard waiting 2 weeks to plant after terminating by crimping can help. From our experience, like it's a mixed result based on the type of cover crop and the type of cash crop you are trying. For example, in hemp, because of the size of the seed, if your cash crop seed size is very small and the residue is thick, then the seed, germinating seed, could adjust all of the resources or the carbohydrate when it reaches the top of the residue. So that time, the light could be a limiting factor for the crop to fully develop the foliage system. So we haven't seen any negative impact on corn and soybean. However, from 1 year experience, the industrial hemp, especially the fiber and seed hemp, Santica and Erlina varieties, they were impacted by the cover crop residue, hairy vetch residue. That's where we are trying to see how, whether there is a true allelopathy. But in case of cereal rye, of course, it has the allelopathy effect on the widths. However, for the crops like corn and soybean, the seed size is really big as compared to the small wheat seeds, and the stand establishment is really great when we tried, and we saw at the growers field. I believe if the cover crop after termination has been killed quickly, you don't need to wait too long in the season to plant your crop. So the another question is like, can you transplant into-rolled cream cover crop? Yes, like in California, we tried transplanting eggplant on unrolled creamed cereal rye and pea mixture. So it was the mixture of the pea and cereal rye, and we rolled and creamed, and then after that we transplanted eggplant and some other vegetable plant. So it did great. So of course, you can do that. Thank you. Thank you for the questions. If you have any more questions, then let us know. Thanks so much for your time.